Let's look at this next example in which we are choosing between two mutually exclusive investments, A and B. A costs $20, and rather than being given the cash flows for the next few years, we are already given the present value of all future cash flows, and that's $40. For project B, it would cost us $100 today, and the present value of all future cash flows is $150. Based on the profitability index rule, which one should you choose? First, the phrase mutually exclusive tells us what? It tells us that we cannot pick more than one project. So one that has the highest profitability index. Actually, the profitability index should be not only the highest, but it should also be above 1, right? Otherwise, if it's between 0 and 1, then it's not a good project. Next, let's calculate the profitability index for each project. For project A, following the calculation of the PI index, we need to take $40, the money we get in the future, and divide by $20, the money that would be invested today. We get 2. It means you double your money. For every $1 invested today, you get $2 back, right? So you get an extra dollar on every dollar invested. For project B, the profitability index is $150 received in the future, divided by $100 invested today. And that equals 1.5. So you less than double your money, you increase your money by 50%, right? For every $1 invested today, you get $1.50 back. Based on the profitability index rule, which is what we are asked to use in this problem, you should choose project A. That's because the profitability index is higher for project A than for project B, right? So this is how we have, compared two projects. However, you may realize that there's something much better about project B. You might actually completely disagree with the profitability index rule conclusion, right? So you might argue that no, project A is not the best one of the two. It's actually project B. Because if you look at the information on the cash flows, right? How much money is actually going to be made, right? The dollar bills. If you start project A, well, you make $40 after spending 20. So in other words, if you instead calculate the net present value for each project, then for project A, that would equal $40, which is the present value of all future cash flows, minus $20, which is the initial investment, and that would give you $20. So $20 is the extra cash you will make. For project B, it's $150 minus $100, which equals $50. So which project has a higher net present value? It's project B, right? You will make $50 if you accept project B, and as opposed to making only $20 if you chose to go with project A. So in this example, we have, a disagreement between the profitability index approach and the net present value approach. The two approaches recommend us to accept the opposite investment opportunities, right? And this may or may not be the case actually. The two approaches may agree with each other, but when they would disagree is when the two projects we are choosing between are of different scale. And different scale refers to different sizes of the initial investment. Right? So if you go back to our problem, then you may notice that project B is 5 times larger than project A. It requires us to invest 5 times more money than into project A. So imagine we made project A similar in size. So let's multiply $20 by 5 to make it also 100. Then if we multiply the future $40 also by 5, that will become $200. So now the net present value for project A is $200 minus $100, which equals $100. And that's more than the $50 NPV for project B. In other words, when we make projects A and B the same in their scale, then you will no longer have this disagreement between the profitability index approach and the net present value approach. In this particular example, both approaches will tell you to go with project A.